Hello. Okay, I guess we can start. So thank you for attending this session. My name is Francois LeMarchand. I'm actually working for Ericsson as a head of product management for SDN. So that includes SDN, but also some of the virtualization infrastructure that we need for virtual EPC or other IP services that we are delivering. And I'm also a representative of Ericsson at the board of OpenDaylight. So the idea of this presentation is to give you an idea about our vision of the SDN solution that we are building in Ericsson, and also to give you an idea across some sample use case. So it, of course, doesn't go into the detail, neither of the technical side nor on the implementation, but just give you also some idea of the use case that we are prioritizing. And, you know, at the end, kind of as a conclusion, you know, what are the functional areas that we think we need to invest on in OpenDaylight, ourselves or with other, let's say, contributors from the community. So to get started, that's basically a slide that has been presented by Eric at the keynote session. So that's what we call the service provider vision from Ericsson. Service provider SDN, why? Because we see SDN, I mean, as going outside of the data center. And as a matter of fact, the first SDN use case that we actually demonstrated and delivered was actually outside of data center. That was based on service chaining, but, you know, with physical box, no virtualization, no NFV, and a physical router to basically, you know, steer the traffic. So we started more on the service layer in terms of functionalities, but then, of course, we are evolving our solution to, of course, encompass data center connectivity, data center virtualization. And moving forward, we also see a strong role of SDN to address the aggregation. So not only about something that is data center that is, you know, restricted to services, but really something you can deploy also in the one environment of the operators, and that will be able to drive metro aggregation or even, you know, some routing functionalities. So different functionality also very important to note is not only the controller has a kind of a cross-domain responsibility across those different domains, right, from the cloud to IP transport to the access management. But of course, if we want to have something that is cross-domain, that is subscriber-aware, service-aware, and so on, then you need to have a strong connection, of course, to the higher layer, which is orchestration, OSS, and also, you know, good support from, you know, northbound API exposure. So that's a bit of the high-level picture. Simplified picture of it, that's basically, you know, the starting point from SDN. SDN controller, split control plane, forwarding plane, protocol OpenFlow initially used as a driver from the forwarding plane, and the first use case being cloud and data center. So the first, you know, API integration point that is very important is the northbound point where the cloud infrastructure can basically program the SDN network as an infrastructure. And that infrastructure can be, of course, either like physical switch, like physical OpenFlow switch, or that could be like a virtual switch. And of course, there is all variant about overlay or not in terms of encapsulation. What we want to point out, and hopefully will be more clear across the presentation, is that we need to work a lot into that northbound interface. Because the first thing that is very important is the integration into the cloud environment. If we look at the operator, the vast majority right now is targeting OpenStack. So that's why our first priority is to basically drive that northbound interface being Neutron, which is the evolution of Quantum. But if you look at Neutron today, it's very basic, right? It doesn't support most of the advanced services, doesn't support layer 3 VPN, doesn't support like more advanced pseudo-wire functionality and so on that you need if you want to address the NFV functionality, or even simply, if not NFV, if you just want to deliver IT application, but in a operator environment, and connect those IT applications, those virtual machines to the enterprise MPLS VPN, then we need to make this Neutron interface evolve. So we are also active in normalization group in OpenStack to evolve that northbound Neutron interface. That's also something that we want to address moving forward on OpenDaylight. There is already this Neutron interface being developed, but we want to evolve it that we can address more use case moving forward. Then if you look at NFV, things becomes a bit more complex because first use case was really SDN just as a resource, just as an infrastructure for cloud. But then when you look at NFV, that's basically, in my view, intersection of cloud and SDN. So you use virtual machine, but not as a consumer of the network services, but as a provider of network services. So we are basically creating another layer of network services on top of the infrastructure, which is the infrastructure is just about connectivity of that VM, but that VM itself provide network services. Whether it's a virtual P gateway, whether it's a virtual PE, whether it's a BNG function, whether it's a firewall function, they're all network services. That could be just, again, high-touch services, just a firewall or NAT, which is the typical and principal use case. But then moving forward, we see more complex services where you want to virtualize the router, you want to virtualize the BNG. And that has a lot of impact about the way the SDN controller is interacting with the cloud. Because in that case, it's not a one-way relationship where basically OpenStack tells the SDN controller how to connect the application. But if the application itself is in the domain of the SDN controller, meaning that the application can be either a full node, control plane, forwarding plane, so more or less take a standard router, BNG, virtualize it. You both have a control plane element, a forwarding plane element. Or that could be, let's say, a simple forwarding plane instance. So it could be a vSwitch, but it could be also a vSwitch that is used as an overlay on top of another vSwitch, because it will be managed by a separate SDN controller, managed for separate services, managed by a different entity. So you also have this overlay model. And then, of course, you may have like pure control plane resources that are virtualized. But as soon as these NFV are part of the services that are delivered by the SDN domain by itself, you basically also need additional connectivity, right, from an API perspective. So it's not only like cloud orchestration using SDN as infrastructure, it's rather the SDN network that is using the cloud as infrastructure. So it's basically telling, OpenStack, CloudStack, and so on, that it needs to have resources, it needs to have new VM instantiated. But the business logic, the decision about spanning these VMs, do you need more firewall? Do you need to connect more subscribers? Where do you need to place those VMs? What type of functionality you need. That logic resides into the SDN controller, because in that model, the SDN controller is not part of the data center infrastructure. That's basically part of some other place, some other organization within the operator that basically manage the service itself. So, for instance, will be data center managed by the IT department, but then this SDN controller is part of the mobility department of the operator. And what they want to do, they want to manage their own NFV, like a packet core, policy servers, GI services. And in that case, it's basically the responsibility of the SDN controller or the service level orchestration to basically use the cloud as a resource to create new VM, to scale those VM, and to configure those VMs. The second thing you can argue, and there is of course different vision, whether or not that orchestration is a separate orchestration layer, or whether it's part of the SDN controller. Also in OpenStack, we see that kind of dichotomy. There is also a question whether the VNF management makes sense to be integrated part of the SDN controller. Because again, if the SDN controller provides the baseline infrastructure about layer 2 or layer 3 connectivity, but then if part of that infrastructure you also see services such as firewall and so on that are basically a basic service that any VM could request when it's instantiated, then it makes sense that the SDN controller itself will orchestrate those services. So will of course not being the one that will trigger the let's say the low-level KVM configuration and so on, hypervisor configuration, but really the one that will basically request the orchestrator, the cloud orchestrator, to book more resources and to basically, of course, redirect and load balance the traffic to those resources. And then if we expand across that service provider vision, then of course, this is not data center centric or not even an overlay on top of data center, but we have to consider also the existing IP network, or transport network that could also be optical or packet optical networks, where you will find a different type of components, right? Because those components typically have their own control plane. It will take a long time if ever everything gets, treated as an SDN network with a split control plane. We're probably going to see a lot of hybrid, which is either SDN controller like putting rule, like SDN-driven rules on a standard router, in addition to the standard router data plane, so it's kind of an hybrid operation, or whether the SDN controller will just slice that network element into kind of overlay networks. So we probably see a number of those use cases. And then finally, if you look at the access, there is of course a lot to be done on the access side. But the most interesting in terms of services and the immediate, I will say, let's say use case is policy management. Because this is where resides all the information about what are the policies we need to apply to a mobile subscriber, to a fixed line subscriber, or to an enterprise customer. So there is two schools. One that says, everything can be solved by the orchestration. So those are different domains. Transport domain, access domain, data center domains. Just overlay, let's say, a magical cloud orchestration, and that will provision, all these different domains and basically create services end-to-end. The reality is probably a bit more complex than that because, first, is it only one service level orchestration that you will have? Probably not. Because if there is different management domain, let's say there is a business service team in the operator, then there is a residential mobile service team, then there is a residential fixed line team as they're organized today. That's probably multiple instances of that cross-domain orchestration. And those different instances have to share the same network. So it's a kind of a multi-tenancy type of use case as well from the orchestration point of view. But then also you can see that this cross-domain orchestration, this is not the standard OSS, right? I mean, many operators are looking now to break away from the standard OSS that are seen as very inflexible, very slow, non-real-time, and so on. And there is a lot of talks about how we can transform that cross-domain orchestration being something much more dynamic, right? That you can, subscribe to a new service for an enterprise customer, and that new service will be deployed in a matter of minutes, right? So by the time of ordering a service, like a new VPN, a new site, in a matter of minutes, you're just activated. But you are still talking about minutes, right? Even though it's very dynamic, the time you activate the session and so on will be between few seconds to a minute to make anything happen. And the idea of this domain orchestration is more static data, right? Like that's the service catalogs, that's the subscription catalog. So there are data that are not transient per nature. So in addition to that, what we see is that the SDN controller needs to have API not only to that service orchestration, but also needs to have more of, I don't know if there are northbound API or east-west or somewhere in between, like northwest or something like that. But the idea of those APIs is that you may need to get much more dynamic information. Let's say a subscriber connects. You want to know where the subscriber connects, what type of policies you need to apply to the subscriber. That's something you need to determine in a matter of seconds and basically apply, or typically even less than a second, hopefully, and then apply the policy and change the network configuration to adapt that subscriber. If you want to reach that level of granularity, of course, we don't want to go to the OSS and back, again to the node. We need to build those transversal interfaces between the SDN controller and those different domains to react to everything that is near real time in that sense. And then, of course, as we look at how SDN controller can control those NFV control plane or can interact with the existing, let's say, IP routers, if you think about I2RS and so on, then you're more in the domain of either like provisioning existing FIB entries and so on in the servers, or like signaling control plane to control plane. So the SDN controller speaking BGP to a router, for instance, to influence the network behavior in real time. And this is really real-time operation. This is a matter of milliseconds. So we need to build more interface on the SDN controller. It's not only everything to the orchestration, but we need to build those northwest interface type of things, and also, of course, the very dynamic southbound interface, whether they are more traditional SDN-centric, which is like a very simple dumb node, and all the intelligence is on the SDN controller, whether this is more this hybrid type of model. So this is more like the way we see, or how we see fit the SDN controller into the overall network domain. What are the applications? And this is just a high-level overview, then I'm going to dive a little bit more on some more practical example. The first layer, and again, our starting point was on the IP services, right? Because our thinking was that this is one of the most, let's say, complex and expensive area for the operators. This is where they have to deal with, like, many vendors. If you look between residential, enterprise, between the different versions and so on, you may end up with 20 or 40 different vendors or boxes across different, let's say, use case, different like market segment, or different vendors or release. You may have like 20, 30, 40 different of those IP service vendors. Think about NAT, firewall, parental control, and so on across the different incarnation. So this is where we felt there is a lot of value of SDN to simplify how you can insert new services, or you can deploy those new services in a flexible way. And that's, service chaining, but again, that's very restrictive. But I'm using it because everybody knows the term and somewhat what it represents. But that's typically what we want to do at this layer, is intelligent chaining of services or traffic redirection based on subscriber activities, based on the traffic, based on the application. Then the underlying infrastructure also need to have SDN intelligence, and that's more about connectivity. And that's connectivity in two ways. One is simple connectivity intra-data center, layer 2 connection, defined by an OVF file, for instance, very simple. But that could be more complex. I was mentioning before, how you want to interconnect easily those NFV function typically, or non-NFV function in the case of an enterprise, to either a mobile access, to fixed residential, or to enterprise. So in that case, it's much more than just saying, okay, you create a simple layer 2 connectivity. Then in that case, we have to interconnect across the WAN. We have to signal the VPN. If you want to automate everything, announce IP routes and so on. So this is actually much more complex, and we cannot build that as an overlay. We need to basically integrate the SDN controller with the existing IP MPLS WAN. So that's not something we can solve easily by an overlay like VXLAN, like something that will be either internal to data center or something that will be between two data centers that are peer from each other. And then finally, maybe it's a bit longer term, but there is also a big push from the operators to figure out, how we can simplify the existing transport aggregation. I mean, some of you that are, from the networking side, you might remember about MPLS TP. Wasn't very successful at the end, but maybe SDN is a new chance to target this problem, right? I mean, the problem that MPLS TP was trying to solve, can we build a much more efficient aggregation than we have today? And MPLS TP was failing because it was too static, too much NMS-centric, or at least the first implementation were not dynamic enough. They were not speaking natively IP MPLS. Again, in terms of insertion in network was quite kind of problematic. But those are all issues of MPLS TP, are issues we can solve with SDN today. So there is actually a new chance for SDN to actually address also the WAN and the transport domain side. So use case, I mean, starting on services. SDN-driven service delivery. What do we mean by that? So you can see on the right-hand side, that's basically an illustration of the typical service chain that the operator deploy. They already do service chaining. So again, like SDN is not solving any problem that is not solved already, but maybe it's not solved in a very efficient way. Because people will say, we do service chaining today, right? Just create some VLAN, you can automate it even a little bit, use PBR policies, you provision through Radius or some interface that you redirect the subscriber to the right chain. But then, of course, there is a lot of limitation about flexibility of redirecting the subscribers, how you, get the packet mirrored on the reverse direction. You have to use kludge like SourceNAT, for instance, to remap the subscriber in a proper way. That's kind of difficult to troubleshoot. So as a result, actually, if you look at the operator, the time it takes them to implement a new service in the chain in real life, that can take months. So it's not like, for an enterprise, probably it's not something that is very relevant. But for an operator with all, like, say, the operational issues and testing and validation, that typically means months to integrate a new service. So the first, let's say, use case we address with our solution is to say, let's make it fully dynamic, that we don't create chains and then map subscriber to chains. We create chain per subscriber, more or less. And we make that completely dynamic. At subscriber bring-up time, then we retrieve dynamically the policy and we provision the subscriber. So the thinking, again, is that for the operator, they will be able to allow the subscriber to subscribe themselves for the services they want, or to insert new services, on the fly. And there is a lot of potential candidates. Of course, there is the more traditional firewall, parental control, and so on. But there is a lot of new use case with optimization, CDN, DPI, charging, advertisement, profiling, header enrichment that exists already, but there is new use case for that that we are looking through. That the operator will benefit from that services. Also, if you think about enterprise services, that also become critical, because when you talk to enterprise and they want, for instance, a virtualized firewall or a virtualized NAT, the big enterprise, they all have their preferred vendors. So some will want, vendor A, vendor B, vendor C. So then this is also a reason why you multiply, multiple vendor of a given type of service. Again, so the idea is that you just have to define the bundle in a GUI interface, and automatically they are available to subscriber, and you don't have to really validate or rebuild or define anything static on the chain definition. So how does it work? And what's the relationship with the overall policy management and orchestration? The first step is typically a subscriber to go to some self-care portal, so it can be more or less complex. Of course, for an enterprise, it will be quite extensive about the selection, the option he can select, which site he connects with what policy. It will change, what type of protocol can go through at which time of the day and so on. But then, of course, if it's a subscriber, that will be much simpler. Will be like, do I want to prioritize Netflix over my background Microsoft downloads, right? That could be something very simple. We always see this kind of policy management being, let's say, customer, let's say, agnostic, not agnostic, but antinomic, in the sense that you're not providing something that will help the consumer, but you will actually trying to, rate limit him or like limit his internet access. But it can actually be very beneficial. If you give the control of that DPI engine to the end customer, for instance, you can bring a lot of value. So First thing to do is like subscription and policy, right? Define the policy for the subscriber, and you can move the policy to a store, to a policy repository database that will be attached to the PCRF or BPCF. So that's the first step. Then, of course, the service level orchestration will need to do three things. The first thing is to create the service, assuming it's like SDN, NFV, and so on. So you have a first step that is, of course, to instantiate the VM for those services. Also figure out, how much resources you need to do, because you don't want to create one VM per subscriber for residential. That will be crazy. So you need to have some form of sharing and scaling, obviously, for those VMs. And then the second step is also to configure the VM themselves. It's not good enough to instantiate. There is many cases where you need to customize the configuration of those VMs. Then how SDN controller play into that? The first thing that SDN needs to do is to be aware of the VM and their location. Where are those services deployed and where they can reach, and how many of those services are deployed and in which data center. Thinking again about a distributed data center model, for instance. Then the way it works is that when a subscriber connects, and the idea again is personalized services, which is native in the mobile. So each subscriber has one device equals one bearer. So you can define like services per subscriber. If you look at fixed line, today doesn't work very well. You have this like routing gateway doing some NAT. You don't know which customer is behind which device as soon as it's behind the NAT. But that's something we are changing gradually, right? With solutions like virtual home gateway, with solutions such as like a Wi-Fi integrated mobility and so on. We want to basically expose the end device and recreate that, let's say, per subscriber session capability. Then the way that marries very well with SDN, because what you do then, the first step is to get information about subscriber connection, and then you can do that with a standard P gateway, BNG, and so on. We'll notify policy management or AAA, sometimes it's integrated like in fix, about a new subscriber connecting. You need to have subscriber session info, where it is connected, what given IP address you have. And then you have to update the session policy to the SDN controller. Then the policy database is the one that will have the subscriber definition. We don't want to build an Oracle database or whatever to have a policy repository for each subscriber of the domain into OpenDaylight, for instance. That wouldn't fly for an operational perspective and so on. We want to carve out or reuse at the maximum the existing policy database, for instance, in the operator. So what we have to build is, again, an interface between that policy domain into the SDN controller to basically get where the subscriber is connected, what is his IP address, what are the services that he has subscribed to, and what is the ordering of those services. And then based on that, the SDN controller has to program the network. He has to do two things. First is that P gateway, BNG, whatever, is like distance in the network. You have to tunnel across the network. So there is some implication in terms of how you tunnel, how you get the content, in a transparent way from the access into the data center or whatever the place where you apply the services. And the second thing is, of course, to chain per subscriber the different services across the GI land. And this is just a start, right? That's just like how we can make things simpler and per subscriber. But that's fairly basic. But it opened the door to many different dimensions. If you look at the subscriber dimension, which is how you apply it, in a pseudo-dynamic way, because it's basically subscriber can opt in or out for services, but that's basically at subscription level. But then you can have additional policies. You can say, you can mix per destination policies, saying what is off-net, what is on-net on the traffic. You may want to apply different redirection rules. Depending on which OTT partner you may be partnering with as an operator. You may want to do it based on performance, depending on the type of service, type of subscriber, or given real-time performance of the service. You may want to take action. And finally, there is also per application. Depending on the application, the type of handset, and so on, you may want to redirect, for instance, the flow to different service instances. So some example of that. You can look, for instance, at a standard, let's say, subscriber chaining. Say subscriber connects. You say that subscriber goes to DPI, goes to security, goes to parental control. That's the baseline service package for that subscriber. And each and every packet is going to eat those three NFV functions. One simple use case as well for SDN in that case, it's not about how to apply services, but also how to optimize the NFV layer. And then assuming this SDN network is actually hardware accelerated, that's basically our implementation where we use, let's say, a high capacity OpenFlow switch that is able to handle, let's say, millions of flows. So it's not like the typical top of the rack switch, for instance, that is quite limited. Then in that case, what you can do, you can start to make exception at the flow level. What does it mean? It means that DPI, for instance, can detect that you're doing like viewing a Netflix stream, or maybe it detects that you're doing a software download. So you may have a very long-lasting session, right? This kind of elephant flows. In that case, you can reprogram the SDN controller, the application itself. So either like a master application, like a DPI controller that will act as a service chain controller in that model, or the application itself can have an interface to the SDN controller and basically trigger the offload for that flow. So we end up with a hierarchical flow switching where you have like the flow for the main subscriber, which is a default path, but then specific flows. You don't want to do that for each and every DNS request and so on, of course, it wouldn't scale. But specific flows, those elephant flow, less than 1% of the flow, more than 90% of the bandwidth, or 80% or whatever. It's more than a Pareto rule in that situation. Then those specific flows you may want to trigger specifically. And this is how you can, for instance, offload a lot of capacity from the NFV, and you offload that to a lower cost per bit system that is actually the OpenFlow switch. Other use case that we support in some form in OpenDaylight already, thanks to the Radware contribution. Although Radware was very centric on a limited use case in terms of DOS protection, but in a general term, instead of adding services or offloading services to the subscriber, you can start with a more lightweight or background security analysis, right? So it could be offline, like looking at NetFlow table to detect DOS attack, like Arbor is doing, right? It can be more online, looking at some heuristics to figure out there is a port scan going on and attack something suspicious. And then based on that, what you can do, you can basically reprogram the SDN controller to mitigate. And you can do two things, of course, is that one, the SDN network itself, again, if you have hardware acceleration, if you can control the routers, you can rate limit, you can prevent, you can sinkhole some of the traffic when it's a DOS attack. You can also program filters to drop malicious packet. But then the last line of defense is, of course, you cannot do everything with hardware. Then you can put additional VM in the path to basically clean the traffic, right, and do a second step analysis and refine, let's say, clean pipe processing. You can also do like more sophisticated intrusion prevention detection or logging, tapping type of functionalities. Then maybe a last use case, right, about why we see the use for service chaining going beyond like simple subscribers. There is also things like optimization. You may say, see the BYOD type of model where a lot of consumers are using their existing, mobile subscription, their existing device, and so on to access enterprise domain. There is a lot of things first we can do, of course, on mobile network, like zero rating this content, accelerating this content on the radio side, doing like specific course and so on. But also on the SDN domain, right, on the IP services domain, there is more that can be done. So for instance, you can measure what is the average latency for, let's say, the enterprise application destination on the internet. So you just look at specific destination and what is the latency. Some of them you don't have to optimize because they are very close by. Some of them you say there is a very high latency because this application is hosted in data center that is far away. And then in that case, maybe there is something I can do for those data. So the first thing you can do, you can update the SDN controller with real-life measurement. They can be background. This DPI doesn't have to be in the past, right? It can be kind of offline DPI, doing more like statistical behaviors analysis. You can also collect things like routing information, right? AS policies, how many AS steps you have in between, what is the performance of a given AS, what are the transit rules, whatever. So you can compute anyway, you can take multiple information sources. Again, they are just examples. And then based on that, the SDN controller can decide to update the chain and redirect only certain source, certain cache, certain source IP address to that cloud optimization function. And then, of course, everything that is residential or that doesn't need optimization can go through. And then, of course, you can combine with the first model that I presented before, which is kind of the offload model, because now you will have done a first level of filtering, but then everything hits that cache optimization function that you assume is quite expensive. But then that cache optimization function can do another pass on the rest of the traffic and then offload the rest as well. So you can really combine things that are like live analysis or inline DPI. You can combine offline DPI type of function, like more statistical analysis. You can look at NetFlow tables, whatever, like information from the existing router environment. You can look, live, content specific, like the application itself knows what best it can cache or not, for instance, and based on that, you can control the infrastructure. So on this point, this is where we see, and we are going to invest quite a bit into OpenDaylight as well, to make sure that you have the ability in OpenDaylight not only to create the flows that are fairly static, like you create a new VM, you create a new VNI, and you be done with it, but something that can be very high performance, very transactional, very fine-grained, like handling flows or handling like more live destination-based offload and so on. That requires some transformation, some optimization on the OpenDaylight code. Right now, we are doing that on our own controller that we have built in-house. And as we are committed to move to OpenDaylight, this is where we have to invest into those optimization. So that's one of the first area where we want to contribute. Okay, second area, data center connectivity. We need routing in data center. Why we think that? Because we need things like load balancing based on IP, and it could be more or less intelligent load balancing depending on the function, like symmetrical and so on, per subscriber, per destination, per user. We need to have like advanced keep alive, performance measurement, and so on, where you can, of course, reinvent the wheel, but then you can also reuse a lot of the routing protocols that exist today to make this happen. More important, there is everything I mentioned before, which is connect an IP services or a gateway to an existing business subscribers, right, through L2 VPN, L3 VPN, and so on. Being able to announce dynamic IP pool. I raise the capacity of my virtual IP gateway. I need to create more subscribers, then I provision more IP pools, then I have to redistribute those IP pools dynamically, right, to the network. So is it something you want to address through the neutron interface, orchestration, DC gateway, or is that something you want to do in a more dynamic way directly from the application itself? And then finally, there is also need of routing, even like geo-redundancy, right, between applications. One of the best way to trigger geo-redundancy, you have to influence the IP aggregation network that is outside of the SDN control, right? That is outside of the SDN domain. So then again, we need routing capabilities in order to interact with that one aggregation. So those are some example use cases why we believe we need to have a routing-based solution in the data center. So the first use case we had for SDN and routing, actually we demonstrated that a few years ago at the MPLS World Congress. That was how we can use SDN controller, but not in a data center. That was about programming a WAN. And it was not for typical layer 2 connectivity, but that was actually for full-blown IP routing functionality. We actually took our IP routing stack, IPOS at that time, and we used this IPOS routing stack on top of the controller. So this way, we can get all the native routing functionality, OSPF, BGP, everything you can do with the routing stack, you can signal natively. So that all SDN control domain that is highlighted by the dotted line looks like one big giant virtual router. So there is a huge benefit for that, because then you can integrate and plug directly into your IP network into your WAN. So that makes it very seamless to basically insert into that domain. Today, if you look at data center, we believe you can mirror that solution. Take an SDN controller, put routing capabilities into the SDN controller, and then you can basically act like if the whole data center is a virtual PE. There is already a number of vendors that are doing this, but for most of them, right now, those vendors, they are like doing that on a proprietary manner. There is, of course, Cisco that is contributing to OpenDaylight and adding like some of the BGP extension and so on. This is a great starting point, because then we can build on top of that and we can build more use case that simply transport more about VPN and connectivity. But then I think something that we see maybe more specific to Ericsson, we believe there is even more value if you use something like OpenFlow as a sourcebound protocol. Because then it means you can do routing, but you can actually do routing with hardware acceleration. You can use, like, say, a white box switch or so on to implement your routing capabilities. So as soon as you say you do that on a vSwitch, right now, the easiest way or the path of least resistance is to say you buy controller A, then you have to use vSwitch A from the same brand, from the same vendor. Then you can use any type of proprietary interface, doesn't matter. Because you say it's hardware agnostic, because it's an NFV, because I can instantiate across any type of environment. But if we look forward, and we believe those NFV or those connectivity function needs to be hardware accelerated, but you don't want to give up any of the flexibility of IP/MPLS routing, then this is where something like OpenFlow, in our view, makes much more sense. So the reason why we contribute OpenFlow in OpenDaylight is not only for, let's say, service chaining, but our view is that also that's something that could be used for routing outside of the data center, left-hand side, but routing inside the data center as well. So being able to provision IP route, but also MPLS labels and so on. So how this will work? Basically, you need, at the minimum, BGP VPN to make it work. Typically, if you want that to have this completely seamless, you may want to support MPLS encapsulation as well in a native way, which means something like LDP or segment routing support in order to announce what label needs to be used, either to reach the data center gateway or to reach directly the vSwitch if you support MPLS in the data center. So you need to create that, announce that connectivity. Again, that could work with hardware acceleration, dedicated DC gateway, or that could work as an overlay. You can create vSwitch that you program with layer 3 routing information. So this is kind of unique combination because right now either OpenFlow, it's either all overlay, all VXLAN, data center, IT-centric. And then, of course, the IP proponents say, yeah, but I have no use of OpenFlow. I cannot interconnect to my routing. I cannot use my routing domain. Or let's say there is a lot of SDN vendors that are using routing in data center, but they are doing that through proprietary protocol or pseudo-proprietary protocol. OpenFlow, in our view, is the only way that we can address it and get best of both worlds in that sense. Of course, there is still some challenge, like we don't support, all the scalability, all the functionalities in OpenFlow that you need for routing, but that's something we're working on normalization, and that's where we think it's important to invest into the OpenFlow southbound protocol in OpenDaylight, so that we can actually increase the capabilities over time, and we stay with the standard, or we even stay ahead of the standard a little bit in terms of OpenFlow definition. So that was the use case before, was between two data centers, but of course, the main use case is when you take a VM in data center and you want to interconnect to an existing PE. Of course, there is different way to do that. You can put some form of border node, DC gateway, stitch the domain, but that becomes very complex in terms of troubleshooting, in terms of operation. It's much more flexible to have this native functionality. Something else I wanted to point out is that in terms of compatibility, right, because there is some issue with MPLS, right? You do MPLS encapsulation, you lose DPDK acceleration, you're not transparent with certain, let's say, top-of-the-rack switch. So it's not a slam dunk either, right, MPLS in data center. But obviously, there is some solution. I mean, we've been doing for years the ability to encapsulate MPLS over IP. So you can make that IP tunneling fully dynamic. Basically, you signal the next stop, the BGP next stop, with the BGP update. So you don't really have to go to SDN controller, provision using wave config a tunnel or whatever. That whole thing is completely dynamic, is completely stateless. You just download the BGP route and the IP next stop. If you don't have a label, you just add a header on top of it. That's what we call soft GRE, right? Which is basically MPLS over GRE in terms of encap, but with a smart, stateless, dynamic control plane on top of it. So using that, that's also an easy way to insert that type of solutions, including in an overlay model. And then if you move out of the data center, right, and you say, okay, now if you have routing in the SDN controller, what are the other use cases that we need to address moving forward? Then there is a lot about routing. How you can control routing based on more like white box, simple solution in the WAN. There is a lot of incentive to say multi-layer control plane, because then multi-layer control plane, we see the IP opto domain, a lot of interest about using SDN as well to control the optical path. There is some interest onto the IP domain, but I think if you get both of them at the same time, this is really where you get something more disruptive in terms of use case and optimization. And this is where the same controller will need to have the complete visibility of IP and complete control of optical. And this is where you can get the most optimal setup between the IP flows, the IP domain, the IP layer, and the optical domain. Getting the shortest path, changing or re-optimizing your optical path moving forward. That's basically the best use case for, let's say, this joint control plane is using SDN. Both centralize both control plane, integrate them into the same controller technology, have rich APIs and multi-layer optimization models. That's how we can get this in a very efficient way. And then finally, if you look at the core network, do you want to have SDN everywhere? Not necessarily. May not be very applicable from a benefit perspective, maybe quite complex to deliver from an operational perspective. Then there is actually an interesting one that is, right now in IP networking, there is a lot of talks around segment routing. We had traffic engineering, RSVPT base for like 15 years. There is very limited deployment of that because that's very complex to configure, to set up, to maintain. But then with segment routing, what you have is something that is like stateless in terms of signaling. You basically just have to stick labels, and each of it's a bit like source routing. The source of the packet will tell what are the different hops that the packet need to follow. You don't have to signal, right, the path up front. So that's actually much more lightweight. And the first use case were based between routers. So it was a router doing like a segment routing in the core, and then a router at the edge doing segment routing at the edge. And they both share this information based on IGP and based on a local policy that is defined with CLI. You say, how you want to map the different type of traffic. This is not necessarily optimal. This is where we see again a big advantage of SDN, because now with SDN, what we can do, we can actually figure out the topology of the network. And instead of having a standard router at the edge, you replace the router by an SDN switch. Then you can have SDN can control fully the application mapping to traffic engineering mapping based on something that is fully programmable based on OpenFlow. So that's a different model. So how this will work? don't be confused because, again, there is already element of that in the current OpenDaylight. There is the PCEP protocol. There is a PCE element as well on it. So there is already the tools you need to do like this type of segment shorting, type of traffic engineering. But where we think, again, there is a slight difference in terms of use case and application. Instead of having a standard router with a control plane where you configure a CLI policy, go to PCP, retrieve the stack, and then apply the stack and do the mapping, you can decide all the mapping directly on the SDN controller. And then if the SDN controller is also has the view of the segment shorting, he knows the label stack that you need to push. Then he can directly push the label stack and directly make the application mapping. So one example here, standard MPLS, based use case, you have this data center SDN controller on the right-hand side, will program some form of DC gateway or OVS switch with label information, right? So you have two apps, two IP address, one blue label, one orange label, that's what you allocate. And you tell this switch, just pop the label and forward to the right VNI, right? Then you announce those labels, you announce both the label for the individual VMs, which is your VPN label, but you also announce the reachability for your switch itself, right? Which is more like your transport label in that sense. Typically what you will do with LDP, for instance. So that the core transport controller can forward that information, or just a simple route reflector, right, in that model, can reflect that information to a different data center distributed into the network. And then this is where you get a bit of SDN magic, is when you get orchestration that says, well, for those two applications in two different data centers, I really want to have a specific course or specific bandwidth guarantee. I want to have 100% bandwidth guarantee for those two applications. I don't want a simple diff-serve course statistical multiplexing. That's not good enough. Then in that model, what you can do, you basically can have this data center controller that will do a request to the core TNC. Again, you can reuse PCP eventually between those two control planes. But you basically have a PCP that doesn't have to return you the full label stack. You don't want that data center controller to deal with the full label stack because you don't want that controller to be aware of the change that happened in the core network, like like a pass protection, something that is overloaded or whatever. You want to constrain that information only on the core controller. You don't want that DC controller also to have a long label stack to program, because guess what? If you want to do that on a Broadcom switch and so on, you cannot put like 15 labels, right? I mean, maybe 15 labels is a bit extreme, but let's say 2 labels is safe, right, for most MPLS encapsulation. If you go more than 2, then you start to hit, let's say, some question marks, right, in some hardware transparency or functionalities. So in that case, you just provide 2 labels. You have to have a stateful PCE, of course, because you have to count the bandwidth that is requested by the different application in the different pools. And then this core TNC has to provide a label that will allow this core TNC to say, you know the source of the VM and you know the destination of the VM, right? And based on that coupled source destination, then you can provide a strong guarantee on the course and the bandwidth allocation. Then you can program simply that label stack to the DC switch. And then the core TNC is the one that is responsible to map that transport label. So you see, you change the color. Instead of providing transparently the blue label or the orange label, and the purple label in that case, that is the default transport label to the switch 2. There is a typo, actually, it should be switch 2 on the right-hand side. So instead of using the purple label, then you will use either the green label or the gray label. For application 1 and application 2. So this identifies the source application and the destination together on that label. Then when you hit this gateway functionality that is controlled by the core network, that core network can use OpenFlow to say, replace, map that application currently into the red path, map the other application to the blue path, based, of course, on latency, on bandwidth requirement, on given state of the network. If anything happens, let's say one path becomes overloaded, you add more capacity in the network, or you lose capacity because you have a failure that happened, all the protection, reallocation, and movement can be fully handled by the core controller. You don't have to interact again with your data center controller. So that's also very scalable, in a sense that you have well-contained domain in terms of, let's say, state of the information between the different domains. So that's, again, we believe a very great use of OpenFlow, where we say, yes, we reuse like standard routers. I mean, not fully standard, because that's not all routers support segment routing yet, but let's say it's a completely standard router model with independent control plane, standard core routers. But then we use SDN where it makes sense, simply at the edge of the data center, to make very intelligent flow mapping and cross guarantee across data center. And that could be application aware, subscriber aware, or anything you want to define as a policy. So that's another use case for OpenFlow. Okay, so just as a summary, what we think needs to happen in OpenDaylight, and we are ready to contribute on this one. But we, of course, I'll say, looking at the community at large, right? Other vendors, other members of the committee to make it happen. Is one, the OpenFlow-driven sourcebound interface. We are already, let's say, driving a lot of the OpenFlow sourcebound protocol, the 1.3 implementation. But then, of course, it's not only about the sourcebound protocol. That's about data model and all the logic that is on top of it that we need to add. We believe that this allows us to drive a full open hardware ecosystem. We have a lot of use case for hybrid ecosystem. So you say, okay, you can use vendor A. Forwarding plane, whether it's software or hardware, because there is specific element, because it's integrated in your hypervisor, because there is specific function you use. But then, if you have OpenFlow on top of it as an overlay, there is certain use case you can always implement, depending on, regardless of the vendor you choose for a given forwarding plane. Then you also get the fine-grained flow control. Think again about application awareness and so on. Second one is IP/MPLS-driven data center connectivity. There is already a lot of building block in OpenDaylight, but we need to create more. Our view is not BGP just for BGP link state, right? Just learning the topology of the network, but it's BGP to basically announce and build connectivity across the data center. And then finally, there is the northbound API, where, of course, Neutron is very simple right now. We believe we need, and we are actually acting on it on the OpenStack to extend Neutron for more VPN use case. We also think that the APIs, you need both very high-level API. Think about API exposure, right? To machine-to-machine use case or whatever. You don't want to disclose any complexity of the network. Doesn't make any sense, right? So the application needs to be very simple. But then, if the northbound application is something that deals with individual subscriber and so on, or like routing plane, you need to expose a lot more about the network capabilities, right? Or the network topology and so on. So we need both to have very high-level API and very low-level API. We need to have, to limit the abstraction depending on what type of northbound application we have. That's a debate I understood we have a lot on the technical community on the southbound layer, but I believe that's a debate we need to have as well on the northbound layer. Okay, so that was the last slide. I hope it gives you like a good idea about our thinking about use case and how we want to evolve OpenDaylight moving forward. Some areas of priority that's not exhaustive, but that should represent quite well what we intend as Ericsson. Any question? Was it all clear? Or I'll be surprised. Do you all agree? Who disagree with that? Who has strong view or opinion that we should not use OpenFlow for routing, or we should not use routing, or OpenDaylight has nothing to do with the one? Okay?
I don't necessarily disagree. I wanted to ask you, what was the toughest decision in coming to your strategy, and what was the alternative that you considered before coming to this strategy?
The toughest decision is more an implementation strategy. Well, there is two tough decisions, of course, right? There is one about adoption, because you can create with the most smart use case, the one that makes the most sense. But then if it's not supported by VMware and this given customer has a specific top of the rack switch that doesn't work and so on, you have to have faith enough in your solution that you push it through the industry and you find partners that eventually it makes it happen. So the question is not so much whether it makes sense, but more like, can you sell it, right? Will it work in real life environment? So there was a bit of that. Then the second thing was more implementation strategy. Because right now, some of this we have work on our existing controller. We believe in open source, we believe in OpenDaylight. We believe that's the only way we can actually get, let's say, a standard adoption of the northbound API. We know, our controller is open, right? We have like open Ericsson SDK. Everyone can code on top of our SDK. But of course, because it's Ericsson specific, right? It will be very hard to attract people on top of that SDK. So we believe that OpenDaylight, there is a lot of potential in the community, in the openness. And the toughest decision is to say, when do we respend the money? Because we don't have infinite money, of course, especially for new and cool stuff, right? That's always a bit a challenge in big organization. So it is like, when do we need to make the move for the money from our existing controller to OpenDaylight? And that, I believe, we have the courage to do it early in the phase, because if you wait too long, you can never do it, right? So it's a bit like where we are right now, which is investing in OpenDaylight and moving existing functionality into OpenDaylight controller.
What are your thoughts about the required transaction performance of northbound interface and parallelism for these multi-domain SDN control scope?
Yeah, it depends how so there is two use cases. There is one about, for instance, where I describe subscriber interaction. So the transaction performance, I don't know very well, but if you make the thinking that you have, I don't know, like 10 million subscribers, 20 million subscribers in a given network, doesn't have to be all controlled by the same SDN controller, the same domain, but that gives you an order of magnitude of subscribers. And those subscribers, they can, go back and forth at 10 minutes to 1 hour type of average connection rate, probably less in most of the mobile environment. That gives you an idea about the transactional requirement, about setting up just per subscriber. Then if you go to per application requirement, like an application says, oh, that's a video flow, I cannot cache it, let's offload, right? Then of course it depends where you put the threshold about, the sensitivity for offload, but it can vary greatly, right? Through hundreds of millions or billions of transactions per second. Then in my view, if we reach that level, I don't think everything should go through the controller itself. In my view, the controller should more act as a kind of a policy enforcement, which will say to the virtual forwarding plane, this application can talk directly to a virtual forwarding plane instance, and then you can have a direct connectivity between the application and forwarding plane instance, but that is constrained in terms of what are the labels, what are the flow, what is the specific table that application can control. So this one way probably to address the scaling. And then the last one is the routing. Learning, I don't know, if you do just like baseline connectivity, let's say create a new subscriber connected to the data center, will be similar to the mobile use case, which I think we can handle quite well. If you start to talk about, okay, SDN controller speaks BGP, but it speaks BGP to hundreds of different BGP speakers, and they each announce the full internet routing, and this is changing a lot. There is actually a lot of headache as well you can get, right? Then the question will be, is that something that lives on top of the northbound, or is more likely something that is integrated into the controller itself, right? And then maybe there's something we can solve not from the northbound, but more from inside the controller, having again like a more flexible SAL as well to reach those performance. So that's my view, but that's not very technical. So again, guys, feel free to comment. But that's more like the product management requirement view in that sense. So, I mean, our view on orchestration, I think, it could make sense to have some of it into the controller itself, like for baseline, like functionalities. There is already contribution or direction into, bundling some NFV function with the controller. I think that makes sense at the baseline. Then, of course, there is a difference between saying an application is created and you need the basic NAT versus I want to create a carrier-grade NAT for my mobile subscriber that will support, any advanced form of DSLite, virtual home gateway type of use case, and so on. So in one case, it's just like a basic infrastructure firewall. The other one is more like a best-of-breed firewall that is like service level type of functionality. Our view is that yes, it will make sense to put some of it, but very limited. But then the rest of it will have to be either an application on top of the controller or really something that lives on top of it, like really part of a service level orchestration. But then in that case, that comes back to the northbound API, right? To have them open enough that you can move that intelligence to some piece that is outside of the controller. So it's clearly not everything inside the controller, because otherwise it doesn't scale. I mean, everything is new and shiny on SDN, right? You create that SDN controller, you can address all the use cases, solve all the world anger, and so on. But then at the end, when you try to put like 20 different IT domains and to 30 different use cases managed by different people, organizational group into one piece of software, regardless of what that piece of software is, that doesn't work, right? So this is where we are also very worried well, not worried, but cautious to design it in a way that a lot of those functions, as we can be split outside of the controller. And we keep the controller really for what is best of, which is network abstraction, scalability, and so on type of characteristics. Yeah. So I guess we are over for questions, but thank you very much.